So we want to create a new project here and then start to experiment with C++. We want to learn Unreal Engine and like how we can use C++ to program interactivity and, stuff that moves around in our levels and so on. So let's just begin here. I launch the Unreal Engine. All right, so here I'll choose games. Next, we'll choose a blank project. Click next, and we'll choose C++ in this case. Maximum quality, and we're not concerned with ray tracing in this case, so I'll disable that. Desktop console, and with starter content. We want a few objects to move around, maybe experiment with collision, so we want the starter content for that. Then I'll go in here. You see, if we type a plus here, it says project names may not contain the following characters plus. There are a bunch of characters that is not allowed in your project names. So what we'll do instead is we'll do pp, so CPP for C++, and we'll call this C++ experiments. So the point with this project here is to create a single project where we can go in and experiment with various things instead of creating a new project each time we want to go in and test our code or, again, experiment, because this can take up a lot of space on your hard drive. And of course, you don't want too many projects. Okay, so I'm just gonna click create project here. It will create the project, generate the project files, and so on. So it'll take a while. Now you'll see this will also launch Visual Studio, and then here the project will also open up. Okay, so we just have this default scene. If we play this, we can move around, navigate around as we normally can. Press escape. So we have in Visual Studio, we have the solution, then we have the Unreal Engine project, we have our C++ experiments. This is our project code goes in here. We have the source code. You'll see we have a bunch of header files and some .cpp files. All right. I'll just expand this. You have the game mode and so on. So what I want to talk about in this first video is some of these things that you'll see. So some of these macros, some of the inheritance that you'll see. We are going to ignore some of these classes that we start off with, like the game mode class, and we are going to talk about UObject. Okay, so in the next section, we're going to create our first class, and we're going to do this from the Unreal Editor. So we're not going to include files here in Visual Studio. We are going to go back into the Unreal Editor, and then we are going to add classes that way. Since using that facility, Unreal goes and sets up a lot of stuff for us that we would have to do manually, and it could also lead to various problems. So that is why I always recommend that when you create new classes, go and do that through the Unreal Editor, okay, the facility that provides. So we'll take a look at how to do that next. Okay, we have a really useful window. Under Window here, under Developer Tools, we go down, you'll see we have the Class Viewer. You can disable the filter here, Actors Only. Now, actors, of course, are these objects such as the chair or the table that we can place in our 3D worlds. And you can see we have a bunch of these actors in here. So you can search, for example, in the content browser. I'll click here to expand. Then you have C++ classes. And in here we have the game mode. And we'll talk about game modes later. But this is a C++ class. If you hover over it, it will say C++ class. So you can search for that game mode. And once you find it, you can right click on it and you can do things like you can create a blueprint class from that, or you can create a new C++ class. You can, for example, then, use this as a base class. So in other words, you'll inherit from this class. You can open the source code and so forth. So we'll be using this in upcoming lessons. So I'll just dock it right here to the right of the content browser. and just go all the way back up again. Okay, next we want to create a class. So what you can do is you can go to C++ classes and go and right click in here and create a new C++ class. Or you can go to File and then go New C++ class. Okay, now the parent class, so what do we want to inherit from here? You have a bunch of options. So later on we'll talk about actor and pawn and all of that. But for now we want to talk about the Unreal Engine class. So the object or UObject. So to see that we need to click Show All Classes. And you can see that this is right at the top here. Okay, if you click this to expand, you can see actor and a bunch of other things. So I'll click on object and click next. So we'll leave it at my object for now, and this here shows the path, so where those files will get created. You can see header file, source file, it's basically in the same path, and then you can see the header file as the .h extension, source file as the .cpp extension. So we're going to leave this, and then I'm just going to click create class. This will take some time to go and create those files. You can see here generating project files and so on. Then Visual Studio should open up if it's not already opened. And here we can see ready. You can see we have my object.cpp and my object.h, the header file. You can see class, CPP experiments, various things like this, these weird like macros. And this is the class name. So you can see that we called it my object, okay, but it has this U prefix. So that is the convention in Unreal Engine. If it derives from a UObject, then you have the U in front of that class name. Also, you can remember that we chose object, okay, to inherit from. So here we inherit from UObject, okay, that U is prefixed there. You will see later on that when we work with actors, the actor name will also have an A in front of it, and it's also a actor and not just actor, okay, if you inherit from that. So these are some conventions that you have to get used to when working in Unreal Engine. Next I want to talk about some of these macros and things, and some of these includes up here. Okay, so a few terms here that we have to review first. A macro, so macros are keywords that are swapped out for code, and now this happens before compile time. So macros in Unreal Engine 4 here will generate code that enables the Unreal Engine 4 editor integration, as we'll see in more detail later. Now this can give weird behavior, so code completion issues, and you'll also get weird errors. And a lot of these errors are difficult to find or hard to debug basically. Okay, next I want to talk about reflection. And this is the ability of a program to introspect or examine itself at runtime. Now, reflection is not native to C++, so Unreal has its own custom system. It's used for detail panel, serialization, garbage collection, and various other things like blueprint and C++ communication. Now, it's important to note that reflection is opt-in, and this means we need to specify the classes, properties, and functions that we want to have participate in the reflection system. It doesn't just participate automatically. And the Unreal Engine header tool, which we'll discuss in a bit more detail later, collects all of this information. We also have something called garbage collection. So Unreal manages memory associated with the project for us, so automatically. So it automatically deletes objects that go out of scope or that are no longer being used, and this frees up memory. The Unreal Engine garbage collection system keeps track of how many variables reference any given object, and when that object is no longer being referenced, it'll get cleaned up, or it'll get deleted basically. So if you have an object dynamically allocated on the heap, and you have a pointer variable that points to that object, right? And as soon as the pointer variable goes out of scope, then it makes sense to delete that object, okay, that variable pointed to. Otherwise, you'll have that, again, dynamically allocated object on the heap, and nothing has access to it. You don't have a way of accessing that object. So again, the Unreal Engine garbage collection system will keep track of how many variables reference any given object, and when the object is no longer being referenced, then it will get cleaned up. I'd also like to mention the Unreal Build tool. Now we'll probably talk about this again in more detail later. I just wanted to mention this here. Now this manages the process of building Unreal Engine 4 source code across a variety of build configurations. A build configuration is basically a collection of project settings that will determine how your project will be built. And the Unreal Build tool supports several targets, like a game, for example, a standalone game, or a client, such as a game again, which is useful for network games, or a server, again for games, or an editor, which extends the Unreal Editor, or a program, which can be a standalone utility program built on top of the Unreal Engine. This does not really concern us at this point. We are only getting started, which is why I mentioned we'll probably get back to the build tool again at a later stage. I'd also like to mention the Unreal Header tool, which is a custom parsing and code generation tool that supports the UObject system. Now, code compilation happens in two phases here. You have the Unreal Header tool that is invoked, and this will parse the C++ headers for Unreal-related class metadata, and it will then generate custom code to implement the various UObject-related features. Okay, then the normal C++ compiler is invoked to compile the results. So basically it's going to go through and analyze those C++ headers. And based on what it finds, it's going to generate custom code to, again, implement UObject features. Once it has generated all of that code, so again, we have these macros, okay, that you basically swap out for custom code as well. So all of that stuff happens, and then again, the compiler is invoked to compile all of your results. So I don't want to explain every single bit of code that we have here. I just want to explain some of the things that are important and why they are here. And as we actually start to program, variables and functions, you'll start to see why some of these macros are used and why they are useful. The pragma1's preprocessor directive will instruct the compiler to only compile this header file once when building the project. So an interesting thing to note, if we take a look at C#, for example, everything is basically an object, right? Now in C# you also have garbage collection, so you don't worry about, managing pointers and all that stuff. Whereas in C++, we as programmers are responsible for memory management. And again, that is handled for us in C#. If you see again here in Unreal Engine, we inherit from something called UObject. And we specify our C++ classes as being Unreal classes with that uClass macro at the top. So it's interesting here because it's almost like we are objectifying our standard C++ classes, right? We are wrapping those up and we are saying, okay, these are now Unreal classes and they can now participate in the reflection system, can be garbage collected and stuff like that. So again, with C++, you don't get this right out of the box. And this is functionality that we get in Unreal Engine by, again, using a combination of some of these macros and so forth. Now, at first you might think, okay, this is supposed to make my life easier as a developer, but it doesn't really feel like it because I'm having to use all of these macros and things. But a big problem with that is people compare it to something like Unity, right? And the thing is, C# and C++ is often compared when it comes to this, but you cannot really compare C# and C++. The only thing that's really similar is some of the syntax. So if you look at loops and conditional statements and stuff like that, but ultimately it's very different languages. You cannot really compare those languages. You can probably compare C# and Python somehow, or C# and the Go language or something like that. But C++ really is kind of on its own currently, and it is a lower level programming language. So you have to look somewhere else. You have to look at real competition like the CryEngine, for example. Now, speaking from experience, if you go and try to create a component or something like that in CryEngine, it's going to be a frustrating experience if you come from Unreal Engine. Not just because of lack of documentation or tutorials, but really because you have to do a lot of extra work. It does not have, at time of recording, a generalized reflection system or database management system. So they are in the process of building those systems, and hopefully that will ship in 2020 or some point. And I'm looking forward to checking out like what they come up with and how it works. If it's easy, like the system that we have in Unreal Engine, but we'll have to wait and see. So you have to compare it with that, and again, from personal experience, this stuff is much easier in Unreal Engine, and I actually switched back to Unreal Engine at some point because of how much easier it is. So I have to look at this from the standpoint of it seems like work, but ultimately it's there to help us in our development efforts. Okay, so another include is the filename.generator.h. So this will mark the header as containing reflected types, and we have these various macros that will go before your declarations, and these can contain additional specifier keywords that we'll see as we go along. Now the Unreal Header tool will harvest or collect information from all of these, and it will generate additional code. Now code generated by macros such as uClass will be located in that classname.generator.h file, and without this include, compilation will fail. I'd also like to note that it has to be the final include. So if you swap generator.h out with some of the other includes, right, then you'll probably get an error. So you don't want to do that. Again, include that generator.h file last. Just as an example here, I'll cut this out, Control X to cut that out, and paste it here. So we have my object.generator.h. So the name of your object, in this case my object.generator.h. And if I build this, you'll see we get one failed. So this build here will fail. And the reason why it fails is it says include found after the .generator.h file. That file should always be the last include in a header. So if I go and swap those around again, make sure the .generator.h is included last, then you can see if I build here, that build will succeed. Again, we can build by simply right clicking on the project and then clicking build. We'll take a look at that again in the next video. Now, gameplay classes use standard C++ code in conjunction with these specialized macros to simplify the process of declaring classes, variables, and functions. So you might think, well, how does this simplify stuff when I have all of these macros? It kind of seems like extra work that I have to do. I don't really want to be dealing with these macros and stuff. I just want to write my game-specific code. Well, actually, this reduces the amount of code that we have to write to expose our classes, variables, and functions to blueprints. So again, a macro is basically a line that gets replaced with a couple of lines of code. So instead of having to write, for example, 10 lines of code each time to specify something as usable, basically in blueprints, for example, we can simply specify that as blueprint read write or whatever the case might be, as we'll see later. So these macros might seem like extra work to write out and stuff like that at first. Like when you look at these classes at first, it might seem like a lot of, stuff that you have to be dealing with. But to actually make life easier for us as developers, as I mentioned previously, you do get some weird errors and stuff. That is possible, but overall it's supposed to make our lives easier as developers. So classes, you mark with the uClass macro. And again, this is how we mark the class to participate in the reflection system. And then you have variables, which you mark with uProperty macro. These are considered properties like floats or integers or whatever the case might be. Again, those variables are properties. Then you have functions, which of course we can mark with the uFunction macro. As I mentioned, again, you also have various specifiers or arguments basically that you can pass in, and we'll see those as we go along. So when programming with Unreal Engine, it's possible to have standard C++ classes, functions, and variables, and these can be defined using standard C++ syntax. But uClass, uFunction, and uProperty macros can be used to make Unreal Engine aware of these new classes, functions, and variables, basically, again via reflection. So an example here is a variable with a declaration prefaced by the uProperty macro, and with it set up like this, it can be garbage collected by the engine, and it can be displayed and edited within the Unreal editor, for example. So uClass here, standard C++ class on steroids, marks it for garbage collection, and I'd also like to note here that uClass object creation and removal is managed by Unreal Engine 4, okay? So we do not use new or delete here, as you might be familiar with standard C++. We basically have a garbage collection system in Unreal Engine, so you need to kind of mark it for removal in a different way. Take a look at how we can do that later. So here again as an example, you can see uClass at the top there, that macro right before your class name. which will inherit from some parent, and then we have the generated body macro as well. Now descriptors such as the class specifiers and metadata are passed to the uClass macro, and these are used to create the uClass for the class being declared, the engine's specialized representation of a class. Now that generated body macro is also required for all the uClasses. Okay, so then we have this projectname.api. This is used as an organizational tool. It basically defines the code set to which your class belongs, and this is necessary if you want to expose the class to other modules or plugins that expose classes to provide functionality across multiple projects. The core minimal header contains various types from Unreal Engine 4's core programming environment, fstring for example, fname, tarray, and so forth. You'll become familiar with these types as we go along. Okay, so that concludes this overview, an introduction to the reflection system and some of the includes that are important. Now in the next video, we'll continue off and we'll actually start to program some stuff, and you'll see how we can expose this to the blueprint systems so we can make these UObjects blueprintable so we can use them in the blueprint system.